All right, here we're looking at section 8.3. And so our learning targets, we're going to be using the side-side-side similarity theorem. So we've used some of these theorems before when we were looking at congruent triangles. So remember our only difference here is we're looking at similar triangles now. So we're going to be using the side-side-side similarity theorem. We're going to be using the side-angle-side similarity theorem. And then we're going to be proving some slope criteria, right, dealing with slope using similar triangles. So here's my side-side-side similarity theorem. And what that says is if the corresponding side lengths of two triangles are proportional, right, we're not talking congruent, so they're not going to be the same, we're talking the proportion, then my triangles are similar. So I noticed if I have AB, if the fraction of AB over RS, remember those are our corresponding sides, is equal to BC over ST, which is equal to CA over TR, then my triangles are similar. Right, and so again, I want to draw my triangles in a way where I can easily spot the corresponding sides. So here, these triangles are drawn that way, so I know that the bottom two would be my corresponding sides, the two that are kind of going up and down this way would be my corresponding sides, and these other long ones would be corresponding. So this can help us by first drawing the triangles in a way that we can see where they're at. So let's look at our example. So the question is either triangle DEF or triangle GHJ similar to triangle ABC? So here I'm given my two triangles and I'm trying to figure out if it's similar to this first one. So the first step I would do is I would redraw these triangles and relabel them, move them so that they're all drawn the same way. So let's see what we're doing here. So I want to compare them by finding the ratios of corresponding side lengths. One thing I can do is I can look at how they're written as well. So I see that AB is are the first two letters in my triangle, so I know that that side length will correspond with DE. So if I look at AB, I see I have 8, and DE would be 6. So then if I simplify that fraction, I end up with 4/3. So now if I look at the longer sides, my CA over DF, right? CA, the last two letters, DF, the outside letters, and I simplify that fraction, and then I look at my remaining side. So I look at BC and I look at EF. And since I see that these ratios are all the same, then I know that those triangles are similar. So now let's look at triangle GHJ. So I can do the same thing by finding my ratios. And again, I can look at the triangles or I can look at the order that the letters are written. That also can help us. So I look at my shorter sides. So I've got 8 over 8. I look at my longer sides and I've got 16 over 16, and then I look at the remaining sides and I say I have 12 over 10. Since these three are not all the same, I can say that they are not similar. So if I would have just stopped after these two, I would have gotten incorrect data. So I have to make sure and look at the side, side, side. That's why I have to have all three to use this theorem. So now here's my second example. I want to find the value of x that makes these two triangles similar. So triangle ABC and DEF. So the first thing I notice is that my triangles are drawn so that I can easily see my corresponding sides. So the first thing I want to do is I want to figure out what my proportion is. So I want to write out my proportion. So I see here that I've got my two numbers that I know, so I can start with that. So I know that the proportion of AB over DE is going to be the same thing, be equal to BC over EF, right? So little triangle over big triangle is equal to little triangle over big triangle. So that's kind of important to remember in our proportions. So now I substitute what I know. So again, little triangle, big triangle, little triangle, big triangle. Then I cross multiply. So 4 times 18 equals 12 times my quantity x minus 1. Then I distribute and I simplify and I solve for x. So now that I can check that my side lengths are proportional, so I just plug in my 7 for x and double check that I get the same proportion. Do I get the same fraction? Which I do. So now I want to find the final length of my triangle. So I know, and I can just double check here as well. So once I found that x, I just double check all of my proportions. So when x equals 7, the triangles are similar by using the side-side-side similarity theorem. So there is another proportion I could have used here instead of this x minus 1 over 18. I also see that I know that the bottom of the triangle, side AC, is corresponding to side DF. So I could have used these two values as well as part of my proportion. Generally, you want to use the one that's the most simple to use and work with. So x minus 1 is more simple and easier to work with than this 3x plus 1. So now here is your first monitoring progress. Try them and see what you get. So here's our side angle side similarity theorem, right? This is our second learning target. So if an angle of one triangle is congruent to an angle of a second triangle and the lengths of the sides including these angles, this is a lot of words, right? So the big thing to notice for the side angle side similarity theorem is that the angle is between the two side lengths that we're talking about. So I would, since we're talking about this angle up top right here and this angle here, which I'm given by this little dash mark, I know that I have to deal with this side length and this side length and this side length and this side length. The angle has to be in between those two side lengths in order for this to work. So if I know that these angles are congruent, and I know that the proportion, my side lengths are in proportion, so xz and mp, and then xy and mn, if these ratios are congruent, then I can say my triangles are similar. So now let's look at our example. So you are building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so it is similar to the left end using angle measurements and the lengths shown? So first we want to draw a picture and just look at the things that were given in our picture, right? So here is kind of here's a triangle, and then here I've got another triangle. I see that I am given the angle measurements, and I see that I'm given some of the lengths. So let's go ahead and see what we know. So I'm told that angle A and angle F are equal, so I can write that. So now I have to compare the ratios of the lengths of the sides that include 53, so the two side lengths that touch that angle. So I see my triangles are already drawn in a way so I can easily see the corresponding. So I'm going to have my shorter sides, right, my big triangle over my little triangle, and I simplify that. Then I have my big triangle, this other side from my big triangle, over my little triangle, and I simplify that. So since I see that these two are the same, my two proportions are the same, I know that using the side angle side similarity theorem, I can say for sure that these triangles are similar because I know this angle and my two side lengths are in proportion. So now go ahead and try these, see what you come up with. So here's just kind of a summary. This was a pretty short section. So here are my triangle similarity theorems. One thing to keep in mind when I know triangles are similar, right, is the angles have to be congruent. So the angles are the same measurement and the sides are proportional. They're not the same length, but they are proportional. These two conditions have to be met in order for us to say that triangles are similar. So there are three different theorems I can use to help us with this. So I can use my angle-angle similarity theorem. So if I know that two angles in my triangle, two corresponding angles are congruent, then my triangles are similar. Then today in this section we looked at the side-side-side similarity theorem, which tells me that if all three of my side lengths are in the same proportion, then my triangles are similar. And then we also looked at the side angle side similarity theorem, where if I know one angle in both of my triangles and the two legs that touch that angle, if those are in proportion, then I can say that my triangles are similar. So I've been able to use these three different theorems to help us. So let's look back at our learning target. So first we used the side-side-side similarity theorem. Then we were able to use the side angle side similarity theorem. Now if you look back in your book, we're not going to spend a lot of time on this one, but look through those pages about proving slope criteria using similar triangles. We're not going to test a lot on this one, so make sure you just go through and look at it and make sure you can kind of explain it and understand it. So now that we've looked through these, go ahead and work on your homework for 8.3.